Hello, everybody. My name is Bradley Wilson, and this is my Statistics 50/30 final project. Introduction. So the objective of the analysis was to come up with a model that predicts the amount of infant deaths in a country based on other data collected within said countries. The data that I used was a study on life expectancy, and I found it on kaggle.com. So the study itself was conducted by the World Health Organization and the Global Health Observatory. So it included lots of information, initially 2,500 rows with information on things like vaccine status for infants, life expectancy for the country, population of the country, and just in general, multiple other statistics that might predict life expectancy, including the country and whether it was a developed or underdeveloped country. And there was also statistics such as like thinness, BMI, things related to health, essentially. And so the link to the original data is in this presentation right here. And so while that's the original data I used, there was some modification that needed to be done so that I could use it for my purposes. So like I said earlier, originally the data contained around 2,500 rows of information for developed and underdeveloped countries. And so this was in the years 2000 through 2015. So for example, Afghanistan had the same information on all those predictors from 2000 to 2015. Luckily, it was separated by year. So to create a model that I thought was going to be accurate, what I did was I chose a year and then did the regression based on that year and in all the countries that had information for that year. So a big issue with this data is that there was a lot of missing values for some of the predictors due to the data being collected on such a large scale. So, I mean, with 2,500 rows and over different years, that's a lot of data to be collecting and compiling. And so I don't know if there were just a lot of lost values or if it was an issue with collection, because it's hard to collect data on this type of scale. And for some countries, it's really hard to estimate or find this kind of data. So that was a big hurdle I had to jump. So the variables for my regression. So like I said earlier, the model was to predict infant deaths. So that is our response variable. And the predictors I chose were hepatitis B immunization coverage amongst 1-year-olds, measles cases reported per 1,000 of the population, polio immunization coverage amongst 1-year-olds, diphtheria immunization coverage amongst 1-year-olds, HIV and AIDS deaths per 1,000 lives births, schooling. So this was the number of years of schooling that the average person goes through in the country. And lastly, the population of the country. So here was our result from the regression on infant deaths on those predictors. So it appeared that the most significant predictors for infant deaths were measles, the schooling level of the country, which once again was measured in years of schooling, and finally, the population of the country. And so over here, we have all the coefficients that go along with the predictors and our intercept. And so when we put this into a model, ultimately it gives us this equation. So infant deaths times the coefficient for hepatitis B times the amount of hepatitis B immunization, same for measles, polio, diphtheria, HIV, AIDS, and you get the general idea. So moving on. What I decided to do next was pick just 3 random countries And it's worth mentioning that the actual infant deaths here all come from the 2015 information. And so what I was doing was trying to use the model on the page before, so this equation right here, to predict infant deaths in the country in 2015. So as you can see, when we compare the results from the calculations to predict infant deaths from our model to the actual amount of infant deaths, there's a pretty large amount of variance between the theoretical and actual results in these three random cases. So for Afghanistan, we had 62 infant deaths reported. And so the model from the page above gave me the number 37.68. So rounding up, it'd be 38 infant deaths. So ultimately, there's a difference of 24 there, which doesn't sound necessarily like a lot, but then we get into the problem of with actual infant deaths in the Democratic People's Republic of Korea, there were 6 and the model gave me 3.32. So this seems a lot closer, but really when you think about it, it's not that much better of a value than percentage-wise than what we got from the difference between Afghanistan and Afghanistan. And then Germany, the actual infant deaths was 2 and the model gave me 47.12. Now, another thing worth mentioning is that in the data modification, when I did deal with those missing values, what I did was replace a lot of the NA information with the median value from the predictors column. So one specific thing that I remember was when I was calculating the value for Germany, the schooling and population numbers were missing. So when those got filled in with the median values, that's not necessarily accurate for the country. And so this could propose a problem, seeing as it would throw our calculations off and ultimately just the data is not true to the country. So the graphs of the regression. So this is a fitted values graph versus residuals from the regression graph. And what we see is a lot of correlation over here. So this isn't necessarily what we want to see when we do the residuals versus fitted values graph. More so we want to see a lot bigger spread and no correlation. And so there's definitely a downward trend here. And so possible remedies for this situation will be discussed in later slides. Now, this was a normal QQ plot for the regression as well. And so here's the model down here and it's incomplete. But so from what we see, there's kind of this S shape. And so, but most of the values fit on a straight line. And so I would go ahead and say that's relatively normal. If not, then maybe it's slightly heavy-tailed, but ultimately a good portion of the values fit on the regression line. And so, yeah. So conclusion, as we saw, the regression is flawed and there's a lot of variance in the actual values given from the data and the values predicted by the regression model for predicting infant deaths. And so what could some people do in the future with this project? Some future ideas would be for someone to investigate all the missing values and ultimately estimate the data or actually go and research the missing values and to paint an accurate picture of what's actually going on in these countries. So that way the data can be more true to each country. And so it's not very plausible in the years, but if somebody were to redo this project and recollect the data, it could possibly be interesting. So in addition, somebody could use a stepwise function in R to optimize the regression model. So to pick the best predictors of infant deaths and regress infant deaths solely on the chosen predictors based on the AIC level. And this wasn't something that I was able to do, just once again due to the missing values and some problems with the data. Let's see. Lastly, someone could look into a model with transformed data. So like we said before, with the fitted values versus residuals plot, somebody could transform the data to make it less correlated. So this has been done by log transformation. Sometimes you can get away with just doing the Y value, and sometimes you have to transform X and Y. But so at the end of the day, the model was kind of disappointing just due to the fact that there was a lot of variance and it wasn't super accurate in being able to predict infant deaths. And so hopefully if somebody decides to investigate this in the future, they can get more information and possibly make it a more accurate model. But otherwise, that's all for today. Thank you.